Hi everyone. I thought of making this video while teaching my students who are preparing for NEET. Usually they complain that they don't like physics. Physics is very tough, or they hate physics. My observation is actually they lack in concept. They can't visualize the physics. So thought of starting from class 9th and 10th as this syllabus will continue in 11th and 12th. Today I am going to discuss about sound waves, which comes under 9th class physics syllabus. Before going to sound waves, we must understand what is wave. Wave, when the word we pronounce, immediately the image comes like this. From where this image is coming? How this is happening? Wave is nothing but a disturbance. Disturbance from where? Disturbance from their equilibrium position. Actually, wave is a disturbance from equilibrium position which travels irrespective of the presence of medium, whether medium is there or not there. Here, particles do not travel, only the disturbance travels. How to understand this? To understand this, we take a rope tied at one end, mark a red dot on the rope and give a jerk to the rope. So you will see a hump like this. After some time, what you will observe? You will observe this hump travels from here to here. Subsequently, the hump travels from here to here. Now it will reach over here. Is this red dot is traveling in the rope? No. So what does it mean? That means particle is not traveling. Particle is only transferring the energy. Particle is moving like this. Particle making to and fro motion. Only the disturbance is traveling. This hump, this disturbance is traveling like this. What is the disturbance in physics right now? Disturbance can be of displacement. Disturbance can be of pressure waves. Pressure, that means we are coming to the sound. If the pressure changes, then we are discussing about the sound waves. So first we will discuss about waves. Broadly, these waves classified into two parts. One is mechanical wave. Second part is non-mechanical wave. What is this mechanical wave? Mechanical wave requires medium. Medium has to be there for the transmission of this type of wave. Non-mechanical wave, no medium is required. Example, sound waves. Here, light waves, electromagnetic waves, especially electromagnetic waves, which do not require medium. Sound wave means it is an elastic wave. That means the body will go like this and it will come like this. That means the particle will move like this. Again it will come back like this. That to and fro motion the particle will make. Then we will classify the waves based on the vibration of the particles. Again, wave is divided into two parts. Transverse wave Then longitudinal waves. What is this transverse wave? Transverse waves. In transverse waves, disturbance vibrates in perpendicular direction to the direction of motion of the waves. Example, the waves on string. Just now we have observed in the rope. That means particle will vibrate like this in y direction and the waves will travel like this in x direction. So this transverse wave, we can see this transverse wave in solids and in liquids. But in longitudinal waves, the disturbance vibrates in a direction as to the direction of the wave, motion of the waves. What does it mean? That means the particle will vibrate like this and the direction of wave motion will be like this. They both are in the same direction. But in transverse, the particle will vibrate like this, but the waves will travel like this. For longitudinal waves, it is found in solid, liquid and in gas. Example, sound waves. So now slowly we are touching the topic sound waves. What is this sound waves? How we are getting sound? Suppose a object, a mobile is there. Are you getting sound? No. When it is vibrating, then we are getting the sound. So sound wave is nothing but a energy. The energy only travels. For the sound wave to travel, we need a medium. Suppose I am talking. How the sound is transmitting? It needs this air. Here air is the medium. So particles, when I am making sound, this sound energy coming from my mouth is vibrating the air particles. And the energy is getting transferred, not the air particles. How to understand that? Now, suppose you are making a sound. While making a sound, now this is your medium, air medium. So particles are there. Like this. Here you are there. Now I am making sound. When I am making sounds, that means I am transferring this sound energy to the set of particles just near the mouth. Now this particle will transfer that energy to the next set of particles. That means particle will move like this and it will give the energy to this set of particles. Then this particle will come back. Elasticity of the medium. Going forward, again coming back. To and from motion. This set of particles again will move forward. Will transfer the energy to next set of particles. Again, this set of particles will move forward and transfer the sound energy. So finally it will reach you. That means your sound is traveling in the form of energy. But particles are not traveling. See, particles are going back, going forward, again coming back. So this is to and fro motion. To and fro motion. To and fro motion. So here what we are observing, particles are not traveling. but the energy is traveling. And how energy is traveling? Particles are only transferring energy. When this is how the sound propagates actually. Propagate means how the sound travels. So while this sound wave is traveling, we will come with two terms, rarefaction and compression. What is this rarefaction and compression? Let us understand. Now, set of air particles are there, like this, and sound, you are making sounds. So this sound energy reaches first set of particles. Now this sound is moving, getting closer and transferring the energy to this set of particles. Now see, at this time you can see particles are getting closer. So that means compression is happening. So compression is happening means here pressure increases, so density increases. Now when this set of particles are moving forward, here you can see less set of air particles. That means here you will see pressure increases, pressure decreases and density also decreasing. So this is called rarefaction. That means particles are in stretched area, very less number of particles there. Now again when this set of particles are transferring energy to this set of particles, so you will see again compression over here. And here again less particles will be available. So this is now rarefaction and this is now compression. So how the sound wave is traveling? Rarefaction and compression. Rarefaction and compressions. So one rarefaction and one compression is one cycle. So for sound waves, one cycle means it consists of one compression and one rarefaction. So since it is a longitudinal wave, so you can see your particle is moving like this and your wave also traveling like this. So they both are in the same directions. So that's why longitudinal wave. Then you can ask, if it is moving like this and wave is traveling like this, then why this wave? Why in every book this transverse type of picture is there for sound waves? Let us understand that. Now, particle is here. It is moving forward, again coming back, again moving forward, again coming back, like this. Now, just change this pattern of image. Moving forward, coming back, moving forward, coming back, moving forward, coming back. Now change it like this. So this is your waveform right now. Hope it is clear now. Now, can you tell me कि sound waves moves faster in solid, liquid or gas? Where the sound propagates faster, in solid or liquid or gas? Obviously the answer will be solid. Very important question. Sounds propagates faster, travels faster in solids. How and why? Now you know in solids it is a close packed structure. Particles are closely packed. So here transferring the energy by the particle will be much more easier if we compare to the gas. So this is solid structure. All the particles are closely packed. Here in gas, it is like this. So much of gaps are there between the particles. Now here, can you tell me whether transfer of energy from this to this, covering this distance for the particle will be easier, or covering these small distances will be easier? Obviously, transferring of energy for the little distance will be much more easier. So it is easier job for the particles to transfer. That's why sound propagates faster in the case of solid than your gases. Hope I am clear about all these small things. Sometimes even question comes in exam कि particle moves or the waves moves. Wave will move. It is a form of energy. Particle will not move. Okay? So you can ask, if it is a to and fro motion, then sound produced, why by vibration, why not oscillation? Why by vibration, why not by oscillations? Oscillations are also to and fro motion. Vibration also to and fro motion. Then why sound is not here? Why sound is by vibration? In subsequent classes, we will study very important characteristics of sound is frequency. Here this to and fro motion, in oscillation, frequency is very less will compare to the vibration. Here frequency is more. That's why we can hear the sound. Hope I am clear with the sound basics. Now, how sound produces? We can take an example. Take a tuning fork. What is this tuning fork? You will see it in the lab. If you strike this tuning fork against a rubber pad, so you will get a tong, a vibration, a sound. And these sounds obviously will travel. Now take this tuning fork and here particles are there. So this is a undisturbed medium. This is a undisturbed medium. Now you are making a sound. So what will happen? So this is undisturbed means this tuning fork is in mean position. It is in mean position. Now move this tuning fork by making this sound will go to this. So what will happen? It will compress the particles near to it. So you will see the particles like this. So this is now compression. In next phase, what you will see? Again, tuning fork, the sound is making to and fro motion. So again the tuning fork will move back to its original position. Rather it will move little bit backward from the main position because of the elasticity. So what you will observe, when it comes back, you will see here stretching of the particles. Compression is over here. So you will see here stretching of particles. So this is your rarefaction. Now one cycle complete. One rarefaction, one compression, and this process will continue. Now again when you will move back, again this tuning fork will move forward. So what will happen? Already we have made one rarefaction, one compression. Now suppose in the next case the tuning fork at this position. So what will you observe? You will see again the compression, again the rarefaction. So this thing will continue. So sound travels in a fashion of one rarefaction and one compression. one rarefaction and one compression. Hope I am clear with this basic concept of production of sound and the propagation of sound, and what do we understand by waves. In next video lecture, I will discuss about the characteristics of waves. Characteristics means frequency, wavelength, time period, loudness, pitch, all those things we will discuss. Hope you like this class, and most probably it will be helpful for you to clear little bit of this fundamental knowledge about the waves, which is very difficult to visualize since physically we can't see waves. Thank you.